There are two different forms of a quadratic equation that you may see. This quadratic function could be in standard form, just like a standard form quadratic equation, where you have the function is equal to that trinomial. Or you could have another form of that function, which is called the vertex form. They call it the vertex form because the vertex is literally located right in it, and you can see that. The vertex is hk, and as you can see in the form, it is there. So the a value is the same in both. If you were to multiply out vertex form, you would get standard form. So as always, if the vertex is hk, then the line x equals h is your axis of symmetry. And if the a is positive, then the parabola opens upward. And if a is less than 0, the parabola opens downward because you would have that reflection over the x-axis. So remember when you are graphing that the pattern for quadratics is perfect squares unless you have some kind of stretch or shrink. So that will help you along the way. But the first thing you'll really need to do before you can graph any of these functions is you need to make sure that you can find that vertex and find the axis of symmetry. So in these questions, I have different forms. So we're going to go through how to find the vertex and the axis of symmetry in each. So if you look at the first equation, if you look at A is already in vertex form. And since it's already in vertex form, I can go right to the answer. So remember that inside this is always x minus h, so that would have to be x minus a -1 to get that +1. So my vertex is going to be -1, comma, and then 3. And because of that, we know because the h value is 1, that our axis of symmetry is going to be x equals -1. So vertex form, it's right there in front of you. B is the same thing. It's also in vertex form. I see all these in vertex forms. That makes that easier. So all these are in vertex form. So this would be 1, comma 4. So remember, it's x minus h. So h is just 1. And then my axis of symmetry would be x equals +1. In C, my vertex would be -4, comma -2. And my axis of symmetry would be -4. And last but not least, D, my vertex would be 1/3, comma, -4/5. And then my axis of symmetry would be x equals 1/3. So as you can see, vertex form, very simple. It's right there in front of you. Just be aware that inside the parentheses, inside that square, is x minus h, not x plus h. Now, if they give you the parabola in standard form, it's a little bit more difficult. You actually have to find it. So the parabola's vertex is going to be, the x value is going to be -b/2a. So you will find that value first. That will also be your axis of symmetry, -b/2a. And then you will plug that value into the function to find your y value. So a little bit more labor intensive, but still very doable. All right, so I have a couple of examples here. So first thing you must do is identify your A, your B, and your C. So our A is -1, our B is 4, and our C is 1. So the x value of my vertex and the way to find my axis of symmetry is -b/2a. So that would be the opposite of 4 over 2 times -1. So that would be -4 over -2, which would be +2. So my axis of symmetry is going to be the line x equals 2. That is also, the 2 is the x value of my vertex. So all I have to do is plug 2 into this equation, into this function, to find the y value of my vertex. So -2 squared plus 4 times 2 plus 1. So that would be -4 plus 8 plus 1, and that is 5. So the y value would be 5. So there is my vertex. And if I wanted to use that vertex, I could say that this function, if I wanted to write it in vertex form, is the a value, which is -1. And that's going to be x minus 2 quantity squared plus 5. So this function in vertex form is the same as this. So it is a nice way to be able to go back and forth. All right, let's try the same thing with the next example. All right, so my A value is 2, my B value is -6, and my C value is -5. So let's plug those into our equation for the axis of symmetry. So -b/2a. So the opposite of b is positive 6, and then 2 times 2 is 4. So 6 over 4, that simplifies to 3 over 2. So my axis of symmetry is x equals 3 halves. I know my vertex is now going to be 3 halves, comma something. And I will plug that into the function to figure that out. So take the function, and I'm going to plug in 3 halves. So that's going to be 2 times 3 halves squared minus 6 times 3 halves minus 5. And this is where, again, you would just use your calculator. This first term, when I plugged that in my calculator, was 9 halves. The second term is 9, and the last term, and the last term is 5. So add those all together, and you get negative 19 halves. So that is the other part of my vertex. And if they did ask you to write the equation in vertex form, it would be f of x equals your a value, which is 2, and then x minus your h value squared, and then plus your y value. So this and this are going to be exactly the same. If you were to multiply it out, you would get the same answer. All right, so make sure you practice with those and then come back for the next lesson and we'll talk about the ways that we can use the vertex to help us identify some features on the graph. So come back next time.